Is this, okay, cool. Yes, thank you for having me. My name is Hayleigh. I'm a front-end developer at a consultancy called Data to Impact, where I do like React and Elm. I'm also a developer relations engineer for an open source company based here in Berlin. I have 2 cats called Haskell and Ada, which maybe tells you a bit about me. And over the last year or two, I've become increasingly involved with the Gleam community. Today, I'm going to be talking to you about end-to-end types, or full-stack web apps and web development in Gleam. I know that types are a bit of a hot topic in the Beam community right now, especially with what's going on with Elixir. And so I thought it would be good to set some expectations or tell you what you might take away from this talk and what I'm not going to touch on. And so the first thing is, I'm not going to tell you that you need to go and rewrite your code base in Gleam today. You don't need to drop your production and pick up Gleam. I'm not going to rave about how great the Beam is. Probably most of you already know that, and you probably know that better than I do. And I'm also not going to preach to you about type safety. I'm not going to tell you that dynamically typed languages are dead and static typing is the future. Instead, my goal today is to get you curious about Gleam, have a think about what the community is up to, and maybe what things you can build with it today. I want to show you one way that types can be useful beyond just type safety. And I want to make front-end seem maybe doable for a lot of you in the audience that might be back-end developers that might have to put together a front-end but really doesn't want to deal with JavaScript and the hellscape of front-end tooling. So just maybe a quick check-in for the audience. Who here had heard of Gleam before the title of this talk? Oh, wow, that's super cool. And how many of you have written some Gleam before today? Okay, cool. That's about what I expected. I think Gleam is kind of known now, but maybe not too many people are using it. So for everyone that maybe hasn't heard of Gleam yet, it's not a framework, it's not a library. I like to describe Gleam as a simple, typed, functional programming language for the web. And I've used this slide as kind of an anchor for other talks that I've given about Gleam. And there I usually break down this sentence into its bits and explain each part. This time I just want to focus on that simple. Gleam's design philosophy is pretty much to be as simple and as approachable as possible. And that kind of manifests in 2 ways. One is an approach to language design in a way that means that we only ever really have one way to express a particular idea or one construct to achieve a particular goal. And the other is to design the syntax and, I guess, the aesthetics of the language to be as appealing to a wider range of developers as possible. So I've used this slide in other talks as well as maybe just an overview of what 70% of your day-to-day reading and writing of Gleam might look like. So, we have imports, we have some compile time constants, functions, let bindings, a pipe operator, which is really, really nice. I come from Elm, I know Elixir has it too. We have pattern matching, result types, all that sort of thing. And it's wrapped up in this kind of Rust, JavaScript-y style syntax, which makes it really approachable for developers coming from other backgrounds to pick up Gleam, either for back-end or front-end work. Of course, Gleam is typed. Compared to Elixir, their research that they're doing into this set theoretic type system is like bleeding edge, state-of-the-art academic research. On the other hand, Gleam's type system is built on the bleeding edge research of, like the 1960s. And so our type system is the same foundation that is used in languages like Haskell or OCaml, but without any of the extra bells and whistles. And I find that this approach to simplicity, both in its type system and in its language design, lets you spend much less time about thinking about how to approach a problem and a lot more time focused on what that solution is. And I have found that to be really productive. And I can say that quite confidently because I've been doing Elm development for the last 5 years now. And Elm shares this kind of design goal for simplicity. Which maybe begs the question, why am I up here talking about Gleam when I could be somewhere else talking about Elm? Elm is just a front-end programming language, so inevitably you need to choose a back-end. One choice that is quite popular is Haskell. Elm and Haskell share a lot of similarities in like its background, but Haskell is like way more complicated, and so if you enjoyed Elm for its simplicity, you have traded that away to get a language that looks similar on the back end. Another obvious choice is TypeScript for your back end, but now you have opened the floodgates to the hellscape that is JavaScript tooling and TypeScript, and also the idioms and the way that you approach writing code in TypeScript is quite different to what you might be used to in functional programming. And especially if you want to lean on an ecosystem of great libraries, you will have to change how you approach solving problems between the front and the back end. And then the last option that I see quite common among Elm developers is choosing Elixir for their back end. I don't think this is necessarily a bad thing that Elixir is dynamically typed, but it is certainly the case that many Elm developers really enjoy the type system, and then they're sacrificing that to get an experience that is nice in other ways for Elixir. So to address this, I've been working on a package called Luster for the last year or so, and this is a front-end framework for Gleam. And it ports Elm's runtime and state management. We'll put a pin in this, and I'll explain why that's interesting in a second. We also get access to Gleam's sane foreign function interface so that we can call JavaScript and Erlang or Elixir as we need. And of course, we now get an excellent backend target for free. So to kind of demonstrate that this stuff works, right? You can actually build interesting things with this already today. I put together this little web app, and this is a step sequencer. So we have a grid of notes and a counter at the bottom. And essentially, whenever we encounter, maybe, okay, we don't have sound. Oh, there we go. Whenever we encounter a step, we play the note. Now, of course, this is just on the front end, but Gleam is a full stack language. And actually, this is multi-client, and this is running, so all the clients are connected on WebSockets, and the changes on one client are reflected in the other. And then we have some additional client-only state at the top that controls how each individual client hears the sound. I mean, obviously, I'm playing these on the same computer, so you don't necessarily hear. Oh! I think that played the other one as well. Yeah. And so just to summarize what that means we have a front end rendered entirely with Gleam. The styling and the UI are provided by a companion package called Luster UI. And this is really nice because this entire web app involved writing maybe like 5 lines of CSS, which is excellent if you maybe don't know too much about design or maybe don't care about design, but you want something that looks and works quite pleasantly. The sound generation is happening through Gleam's FFI to JavaScript, calling the Web Audio API. We have these multiple clients connected over WebSockets, and the backend is written in pure Gleam as well. So we're not depending on any Erlang or Elixir for that. I said we'd put a pin into this and talk about why this is interesting. Elm, unlike most other web frameworks, has a fairly different view of how your front end should work. And it comes with a runtime and a very opinionated state management system on top. This is called the Elm architecture in that community, or the model view update architecture in kind of like the wider front-end community. We have some sort of model which represents our application state. We render that to the DOM as our view. We have a function to render that. As the user interacts with our web page, they produce events which emit messages, and those messages go to an update function that takes a message and the old application state and then returns a new one. And this loop goes round and round. I hope maybe for some of you this update loop looks a bit familiar. This is taken from Learn You Some Erlang, and this is a diagram of a process, an OTP process. And it's the same. We have some initial state, and then we have this event loop where we receive messages, do something until the program ends. And this is a really interesting revelation, because it means that you can kind of think about the client as just another process. And I think this is really powerful, because it means you can take some of your knowledge and experience as a back-end developer and directly apply that to the way that you approach problems on the front end. And to maybe just hit this point home, we'll quickly build a Lustre application. We'll build just a simple counter. We'll start with our model. This is not too complicated. We'll just type alias an integer, and we'll have an init function that returns 0. Our message type describes all of the ways that the world can talk to our app, so all of the events that we can respond to. And so we have a message for incrementing the count and decrementing it, and then we handle that in our update function. And then we have a view, which takes the model and then uses Lustre's DSL for HTML to produce some markup. I've bolded some of these function calls because these are actually the primitives provided by Lustre UI. And then we end up with something like this. You click the button and it updates the count, and it's all good. Now, I have quite a lot of experience doing this style or working on these kind of apps with Elm, and I like to approach this in a type-driven sense. And what that means is I'm always thinking about what is the UI that I'm working on, and how can I represent that with some state. And so this is our application. We know that we need some sort of type, some sort of state to hold the application state. So we look at the first kind of chunk of UI, and we have these controls for the waveform. And so, okay, I need a field to hold the wave. And then I put in this type called waveform. Well, we haven't defined that yet, but we know that at some point we're going to go back and define that. And then the same for the delay time. Then moving down, we have our rows and a step sequencer. You can model this as a list, which I normally do because I'm lazy, but this time I decided to use a map of node names to a row. And again, as we're going through this process, we then are thinking about what is a row, and maybe a row is just a list of like booleans, whether it's saying it's on or off, maybe it's something more sophisticated. And then finally, we have the state of the sequencer itself, whether it's running, and what step we're currently on. And then, of course, we need to think about the messages that our application needs to handle, the events that the UI can produce. So maybe when you click on one of these steps, we send a toggle step message with the note. and the index for the step to toggle. We have some controls for the waveform and so on. And actually, when I was building this application, this process translated perfectly over to the backend. And so, okay, I need to think about what is the state that my main sort of backend process needs to have. A subject is a really thin wrapper in abstraction in Gleam for typed communication across processes. And so here we're just saying we're storing a reference to a subject that I can send a message to myself, which we use for the timer. We have a set for connected clients. And then we have some of that other state that we've seen already, the rows of the sequencer, whether it's running, and so on. And then, of course, we define a message type as well. This process is still the same. And actually, when we go through this, before we've even thought about implementation, we might notice that we have some shared state here. Right? Our client needs to know about the rows and whether the sequence is running. And obviously, our backend needs to know because it's the one that's coordinating that. And because we're in a typed language, we can pull this out into a type of its own. Maybe we just call it shared or state or something like that. And that means if we change it, we get an error everywhere else in our code base. And then we're forced to handle that change in the client and the front end. We can't, the client and the server, sorry. We can't forget to handle it in one place or another. And then just finally, we have some messages to glue the communication between the client and the server. This application turned out to be quite simple in this regard. And so we have a single message that the server broadcasts to all clients, which is just update that shared bit of state that you have into this new one. And then the client needs to tell the server when they click play and whenever they toggle a note. I mentioned that this was written entirely in Gleam, and so I just want to take a moment to walk through some of the main packages and parts of the ecosystem that make that possible. The first one is a package called Mist. Mist is a web server written in pure Gleam, and it's really fast. About a year ago, which is I think the last time we ran a benchmark, it was benchmarking consistently higher, consistently faster than Cowboy, for example, and it was doing a pretty good job at competing with some other technologies. And this web server can handle HTTP, WebSockets, and also streaming for large requests. On top of that is a simple web framework called Wisp. I lied here and I said it's built on top of Mist, and that actually isn't true. It has an adapter for Mist, but you can also plug it into other backends as well. And this web framework provides static asset handling, routing, all that kind of good stuff in a very, very simple package. And it's excellently documented. There's a whole bunch of examples. The whole thing is just one module. It's really, really nice. And the last package that I just want to call attention to is this package called Codec. Gleam doesn't have macros or any compile time code execution, which means when you want to transport something from the client to the server or back again, you need to write some code that encodes your types and your data into something the network can understand. Now, typically, we would do that using Gleam JSON, which is an official package. And then we would use another package, another module in the standard library, called Gleam Dynamic to then decode things. Codec is a package that provides a really nice unified API for producing both encoders and decoders that are guaranteed to stay in sync. And this package is maintained by the Gleam community organization, which, as the name implies, is a community-run organization that maintains packages that maybe are very useful or very impactful, but not necessarily appropriate for the official Gleam organization. And I just wanted to show you briefly what that looks like, because this kind of boilerplate is unfortunately a necessary evil when you have a language like Gleam that doesn't have a lot of magic. But But the nice thing is that this is fairly rote, right? Like there's not a lot of complex things going on here. We create some encoders for each of our message variants, and then we just have this function that says, when you receive a ping, use this decoder, or when you receive a start, use this one, and so on. And then finally then, bringing it back round, I'm going to talk a little bit more about Lustre and Lustre UI. This is the init function for this particular front end. It's mostly that model that I showed before with a few extra bits. And so we have the back end, which represents the WebSocket connection to the server. We have this context, which is an audio context, which we need to use to actually do the sound generation. But the thing that I want to draw your attention to is the return type of this function. We're not just returning the model here, we're returning this thing called an effect. And so actually I lied to you slightly when I showed you the Elm architecture. There's an extra bit to this, and that's that runtime component. This version only receives events from the HTML that you produced, from the DOM. But of course, we want to do more than that. We want to respond to network requests, or in this case, WebSockets. And so we have a runtime that handles that for us. Elm calls them commands. In Lustre, I call them effects because I think it covers the idea more. Basically, these are side effects that we want the runtime to perform, and then we can optionally tell them how to get the result back into our program as a message. And so here I'm batching, which is basically just performing two effects. The first is initializing the WebSocket connection. This package, Lustre WebSocket, is not maintained by me, but it's really, really cool to have. And the onWebSocket event function just takes WebSocket events and turns them into messages that our app can understand. I'm going to skip over talking about the update loop again, because I think probably everyone is quite comfortable with this idea of receiving messages and updating state. And instead, I want to focus on the UI. And I just want to pull out this bit of UI that we had. So this is some sort of set of controls. We have a label, some buttons. And I just want to talk about how you would render this in Lustre, because I think it's quite useful to see how Lustre UI in particular works. So we have this layouting function called an aside, which basically takes two chunks of HTML to render. One is kind of like a main piece of content, and then, as maybe the name implies, some other smaller content to put alongside it. And without you having to write any CSS or anything like that, this is fully responsive, and so if the viewport gets too slim, the side content will just go and move neatly underneath the main content. And then we have some of these functions to configure what that means. And so content last here says, normally you render that main piece of content first, and then you have the aside, and this just flips that order around. And anchor center says, make sure everything is vertically aligned. Then there's another one called a cluster, and this renders things in a row, but things that can be of different lengths, different widths. And this has the same overflowing property as, say, text does, and so as the viewport gets slimmer, these things naturally move on to the next line. You get like a jagged line like you would do if you were writing text. And then we have these four waveform buttons, and these are just really, really thin wrappers around Lustre UI's own button component. And then at the bottom, we're just rendering a paragraph HTML element with the text. Okay, maybe recap what we've talked about today. One of the things I really, really want you to internalize is that Gleam is simple, and Gleam is designed to be approachable. And also that Lustre lets you use your knowledge of back-end development quite directly on the front end through this kind of realization that you can think about your front end as another process. And that finally, the Gleam ecosystem is growing and also already really usable for some things. If you have any questions about Lustre or you want to learn more about Lustre, you can go to the website, lustre.build. If you have any questions for the community or you just want to talk and hang out, this is the official Gleam Discord server. Maybe a QR code would have been better than a very cryptic URL, but you know, you can take a photo if you're interested. And finally, if you want to learn a bit more about Gleam, because this wasn't a tutorial for Gleam, then I recommend you check out the official webpage, gleam.run. Thank you very much. Open for questions, I think.
Hi. My question is, you know, for example, from Elixir, you could use Erlang code and vice versa. How is the compatibility of Gleam with the rest of the ecosystem?
Yeah, the FFI is dead simple. So you can declare an external function, and you just say it's this Erlang or Elixir module, and I give it this type, and it's this function name. And yes. So you can use Gleam already in Erlang. We have like a rebar plugin. I think rebar is the build tool. We also have a mix recipe. Is that what they're called? Something like that. We have that. So you can write Gleam code in your Elixir or your Erlang code bases.
Yeah, so I saw the DSL for the HTML. That's part of the Lustre framework. Looks interesting, but in my experience, these kinds of DSLs always look very nice until you need to do something that's kind of diverting from the simple examples. Is there an escape hatch that's part of this DSL, or?
There is no escape hatch, but I'm struggling to think of examples where you would necessarily need one. Do you have a more concrete example?
Well, when you have HTML, like I don't really know how the DSL works, of course, but maybe you need specific attributes.
Yeah, that you can do all of that with Lustre's HTML DSL. And so I think the easiest way to think about it is if you imagine a chunk of HTML in your head, the way that you would render that in using Lustre is the tags are functions, the attributes are a list of attributes, and then the children is a second list. And so you can write arbitrary attributes, you can have arbitrary children. It's all very nice. So yeah, maybe let me just point that out again. And so like this aside and this cluster and stuff, these are provided by Lustre UI, which is like this second package, higher level component package. Lustre itself has this like very, very straight DSL for constructing straight HTML. And this is the same API that we use in Elm. And like my experience with Elm is that the only time you might need an escape hatch is if you want to render some HTML from the server, like as a string. And you can do that with Gleam, basically, with the FFI. You can inject that and that would work.
Thanks for a great talk. So, if I understood correctly, you can use codec to define the shape of data, the protocol that you consume, and also to enable your code to actually use that data that you consume in JSON. I'm wondering if you make the effort to encode all of that using codec. Is there a way to export this definition, this schema, somehow for consumption from possibly even other programming languages? So in short, is there a way to export a schema or a JSON type definition or anything like this once we have all of that defined in Gleam?
Currently there isn't, but there's no reason why that wouldn't be possible. Like particularly within the package itself, it already has all of that information, right? And so it would be very possible to emit, say, a JSON schema for this. It doesn't at the moment, but maybe I'll do that this weekend for Spawnfest.
Hi, thanks for the talk. One of the questions you said is that performance-wise, that Gleam was in some instances faster than Cowboy when you were looking at it. To what specifically, or what changes, or what about Gleam on the beam makes that performance comparable or better than Cowboy in some situations? Or to what do you attribute that?
That is an excellent question, and one that I think I am wholly unqualified to answer. I have no idea why Mist is faster than Cowboy. I couldn't tell you, but I can, if you want to talk maybe afterwards, I can link you to the benchmarks. The benchmark suite is on GitHub, and so you can take a look there. I've got no idea. I don't think that necessarily Gleam itself is any, I don't think you could say that Gleam is faster than Erlang or Elixir. That would be silly. Gleam compiles to Erlang. But I suppose you could make an argument that when you think about your development through the lens of types, then that maybe pushes you into particular patterns that might end up being more performant. Just because you can't do slightly janky things when you're handling a lot of different stuff, right? You're confined by the types.
All right. Let's thank Hayleigh again.
Thank you very much.